Well, it'll be a small crowd, but I think a lot of people are here in spirit. So, I'm Duane Benson. I'm a full-time journalist and consultant, more journalist than consultant. I used to be in software and hardware manufacturing. I've got a 30-year plus career that has covered a lot of different areas, and I feel pretty lucky about it. So I get to see a lot of different technology. As a journalist these days, I feel even luckier because I'm really getting exposed to some of the new leading edge hardware, artificial intelligence, machine learning, tensor processing, all of that kind of stuff that is having a big effect on us. Well, right now, I think the biggest effect that like generative AI, ChatGPT is it becomes really easy to create or to have the artificial intelligence write things that sound really good, but are not quite accurate. I think that's what most of us see from artificial intelligence these days, but I'm exposed to that plus edge AI and a lot of the other stuff. However, that's not what I'm talking about today. Okay, so are any of you old enough to have had something like this? You don't have to answer this. As one of your first radios. This is a 1935, it's the chassis from a 1935 RCA F65 console radio. So you can imagine 1939, towards the end of the Great Depression, World War II's heating up in Europe and the family sitting around. You've got the warm glow of the tubes. You've got everybody listening to what's going on around in the world, or listening to some jazz. All the things that happened in the 30s and 40s, people sat around and listened to this radio and radios like it. I think they're really cool. Some of my first radios were tube radios that I bought in garage sales. I'd hide under my bed with the tube radio listening to Dr. Demento Sunday night, staying up too late to go to school the next morning. If I'm speaking a foreign language, I don't care. But tube radios are really cool. Now, they're artifacts at this point, and you see a fair number of them, but very few of them actually work, and the reason most of them don't work anymore, well, it's multifaceted, but, sorry, all those capacitors in there, those big cardboard tubes, and waxy covered cylinders, those are capacitors. And if you spend much time with old analog electronics, you know that capacitors dry out and crack, and despite the reputation that tubes have for burning out, they're basically light bulbs, it's the capacitors that are the problem in most of these old radios. They dry out and they short out, they give different values and things like that. So if you want to bring one of these things back to life, you can replace all those capacitors. You can actually get kits for many of them that'll have all of the capacitors that you need. That's a lot of work, and I didn't feel like doing that. So I thought, how about if I turn this thing into a Bluetooth radio? Well, you can throw an Amazon Alexa or Google Home into the chassis and just say, hey Google, play some old music or something. You can do that, and that's kind of cool. It's nice, and when it's playing, you can't really tell the difference. But what I wanted is the effect that goes with it. So if you've never actually used a tube radio, you turn it on, and I would be able to show you this, except I broke some wires or something in transporting this here. You turn it on, and nothing happens instantly. There's some pilot lights up front that slowly glow up. It's from dark to light to show the dial. So they aren't instant on like an LED. It's a whoop. So that happens. And then you wait. And then slowly, the back of the radio starts to glow orange with the tubes. And about halfway through that process, you start to hear the music crackling and gradually raising up in volume until, after somewhere between a minute and 2 or 3 minutes, you have your nice, smooth jazz or Franklin Delano Roosevelt talking about the New Deal or something like that on the radio. It's a really cool experience, and it's so much more than the sound. And when you're listening to the radios, especially on an old AM radio, amplitude modulated, it's a warm sound, it's crackling, it's popping. It's a very different experience. So I wanted to duplicate that with this. And I thought, okay, I could recapacitor it all. I did go through the stage of, I've got this Bluetooth speaker, and I thought, well, maybe if I wire this into the microcontroller, I can use the microcontroller to change the volume on this and all of that, but you know, this has its own firmware. You turn it on and it does thing, it beeps and boops, and I didn't want any of that. So after wiring it up and fiddling it with it for a while, I discarded this solution. And that brought me to the ESP32, which is kind of the main part of this talk here. Well, I don't know what the main part is, but the ESP32, how many of you are familiar with it? Okay, so a lot of people have some good familiarity with it, but if you don't, it is a small chip that is built into a variety of different modules, and it has built-in Wi-Fi support and built-in Bluetooth support at various levels. So it's got a microcontroller, Bluetooth, and Wi-Fi. It's got all of that built into it, and that's an amazing combination. A few years back to get that, it was, you know, kind of crazy in terms of the amount of hardware you'd have to wire together and software and all of that. Well, the ESP32 has a really good community supporting it as well. So I thought, I will go ahead and use an ESP32. So that's why I'm here today. So first of all, I kind of already talked about this, but I always like to get on a soapbox a little bit too. You know, I'm a bit of an oldster in terms of electronics, and many people my age have kind of stopped. And whether you're a young person, somewhere in between, someone my age or whatever, the thing that I like to talk about is never stop. You know, you don't have to be afraid of things like this. I don't think any of us worked on these, you know, as original electronics, but you can go from that to this, or you can go from transistors or microcontrollers to this. You don't have to stop. There's such an incredible community of people out there, and such a wide variety of resources out there. One of the first DIY projects I ever tried to do this is before caller ID was public, but I had learned that on the old phone system back in the 80s, hey, I've heard that they're sending the number that's dialed along the phone before it rings. So they digitally sent that with DTMF codes, dual tone multi-frequency. That's the old push button phones. They sent that, and I thought, well, that's cool. Why don't I build something to decode that so I can see who's calling me? And if you're a nerd, never name products yourself, because I named mine the PLTD, Private Line Tracing Device. Caller ID is so much nicer. So I had to get out pen and paper. I had to go to libraries and look up AT&T and the FCC and all of these places. I had to look up addresses for these places and write letters to them all and say, can you please send me this documentation? And about 6 months later, I had a nice set of documentation on how this all worked, and it was pretty amazing. But by then, people in the industry had already, you know, designed and released it. So today, you can get this stuff in a weekend. You can create stuff with something like this. And by the way, this one here has a little microcontroller, Wi-Fi, Bluetooth. I think it might even be an ARM microcontroller in here. It was like $6. I mean, how can you, if you want to play with something, if you love technology, if you want to learn, how can you avoid doing that? It plugs into the USB 3.0. You can program it in Python, which I have done a little of, or with the Arduino IDE, which is what I ended up finishing these things up. So you've got kind of everything you really need in these little products for success. And that's one of the beauties of the ESP32. You can make remote controls. You can make little devices so that when your car pulls up to your garage door, it talks to another one, and the two of them securely know who they are and open your garage door for you. Someone else can't do that. All of these things for a handful of dollars, and the software to write it is really pretty easy. So, oh, that brings me to my second project here. Another ancient technology. Hello. He remembers these, state-of-the-art 1951 Model F from Western Electric. So I thought, numeric keypad. And I thought, well, gee, that's really easy. You count the pulses, you know? No big deal. It's not quite that easy, but I'll get back to that later. So anyway, back to the first project. As I said, it's a 1935 GE Model 65 super heterodyne radio. So everybody here probably knows about software-defined radio, right? SDR. Before SDR, we had analog radio, and primarily in digital, or in AM, amplitude modulated, or FM, frequently modulated bands. AM radio used a circuit called a super heterodyne, which amplifies and processes audio, or processes the signal in radio frequency, audio frequency, and intermediate frequency. I had to do that out of order. So this particular circuit, the super heterodyne circuit, was created in the late 20s and early 30s. Before that, they had what was called a TRF, tuned radio frequency, very broadband, very distortiony, very noisy, but you could kind of pick out radio stations. This particular 6-tube super heterodyne circuit, developed in the late 20s, early 30s, lasted until we came up with software-defined radio. So tubes to transistors to integrated circuits, this was a very long-lasting circuit. And again, I thought rather than taking this beautiful piece of electronic art from decades past and just throwing it away, I actually bought this one at a garage sale, and I was walking out the door, the people said, $20 or it goes to the landfill. Can't do that, can't do that. So I actually found the schematic diagram for this online. So that has, you've got your, that looks like, so over there, there's the tuner. Here's the power supply down here. Power supply here, tuner, intermediate frequency, and we've got transformers to translate impedance between radio frequency, intermediate frequency, and audio frequency. And over here is the audio amplifier section. Pretty complex circuitry for back then, but again, it works well enough that that basic design lasted from tubes to transistors to integrated circuits. And again, I did not want to discard that. And then the other thing, the other project, number 2, like I said, is how many of you have actually had to use a dial phone? Okay, that's pretty good. None of us are going to be like transported back in time, walk up to an old phone booth and not know what to do. We've got it figured out. So this was a really fun one too, because what I've got here, it is an electric device. I would not call it an electronic device. It's really a mechanical computing device. And inside the inside that little amber part, there's a set of gears and cams and wheels that is essentially a mechanical state machine. And so what I had to do, the first thing I had to do was reverse engineer that mechanical state machine. My initial thought was, you just count the pulses. Well, when the handset is down or on the hook, you don't want to count the pulses. Okay, so this state machine on hook, state machine off hook. But now you don't want to count the pulses when you're going back that way, only that way. So that's another state, dialing backwards. And then you have to have a pause between the two. Well, there's another cam that tells me when I'm paused so that it doesn't combine, a 2 and a 4 to get a 6. So I decoded all of that and brought it out to my ESP32 again. And with the state machine, I was able to determine when I should be counting numbers, and I don't know if I've ripped all that apart or not. Originally, I wanted to do that one with Bluetooth. Yes.
Weird question. Could you just double the count, or does it have a different number of clicks going one way than the other?
It actually, with the cams in there, with the mechanical cams, it actually prevents it from counting.
Oh, okay.
So whoever designed the mechanism, and the actual mechanism goes back to the 1920s even, excuse me, and was virtually unchanged until push-button phones showed up. So the cam locks it out. So I don't have to worry about that. I spent some time thinking about that. I spent some time architecting the code to deal with that, and then it turns out I don't have to worry about it. So again, options, and then once I decided to Bluetooth these things, I had a couple of different options. At first I thought, well, I'm very familiar with PIC microcontrollers. I will use a PIC microcontroller, I'll use a Bluetooth module here from, that's another microchip Bluetooth module, and I thought, well, I'll just do all that, program it all from scratch. Well, Bluetooth is one of two things depending on how you do it. Incredibly complicated, build it from scratch. Incredibly easy, using something that someone else did. So I have that little module there. It's actually, those are, I think, 0.5 millimeter pitch castellated connectors. So even soldering it up would have been an awful lot of fun. I decided against that, and that's where I came up to, I will cannibalize an existing Bluetooth device. And when I tried to do that, I was able to control it, but it still makes its own sounds, it has its own pause, and all of these other things that go along with it. And then I thought, well, I could just sort of create my own firmware for this so that it wouldn't do that, but no, that's a lot of work. And that's how I then settled on the ESP32, and I have lost count of how many variations of ESP32 there are. There are so many of them. Some of them are are tiny, tiny little, barely powerful microcontrollers. I think they're all at least ARM though, and some of them are pretty powerful with a good set of functionality. The one thing that is important to note, though, if you are going to use one of these things, is look at the exact capabilities. A lot of them do Bluetooth. I mean, all of them do Wi-Fi. A lot of them do Bluetooth. Some of them do Bluetooth low energy. Some of them do Bluetooth 5.0, but amongst all of those different Bluetooth standards, audio isn't always included. So that one on the left, and a couple of these here that I've got, wherever I put them. Oh, here they are. A couple of these have Bluetooth, including Bluetooth 5.0, but no Bluetooth audio. So I'm writing the code and getting everything to work, and then looking for libraries online, and there weren't any. Okay, so I had to change modules. But this one, so the one I got, I think it's a C4 that has the Bluetooth capability built into it. And now when you're using a Bluetooth, you've got a couple of different language choices. So you can use the Wi-Fi, of course, and the Bluetooth, and provided it has the right kind of Bluetooth, now you're on to programming it. And once you're on to programming it, you need to choose your environment, your development environment, as of course the board. And the two major development environments used by ESP32 are Python of some sort and the Arduino IDE. They also have native code. You can get a plugin for Eclipse or other standard integrated development environments. I stay away from that. I was talking to someone here earlier today who said that the ESPs these days integrate much better with the IDFs, with the integrated development environments than they used to. So if you want to do that, you can use C or C++. Excuse me. But I've had bad experiences with that, and so I just decided I would use Python. And Python comes in a couple of different varieties. There's standard Python, which you use on your computer. For microcontrollers, you have two choices. You have circuit Python, which is oriented primarily around microcontroller devices that are produced by Adafruit or sold by Adafruit. So they ported Python a number of years ago. They call it CircuitPython. It's got a pretty good set of support, but it doesn't support everything. Different thread, MicroPython, somebody else took it upon themselves, or another group, to do the same thing, port Python to a microcontroller, and theirs is called MicroPython. The two are very, very similar, but you can't use a library from one to the other, and syntax varies just a little bit between the two. So what I did is I essentially looked through the libraries that were available and found the best set in MicroPython and worked from there. So both of these things, I started out programming in MicroPython. Now, with the Bluetooth audio here, I ran into a problem in that the particular ESP32 variation that I have, I could not find a Bluetooth audio library for it in MicroPython. The chip is capable of doing it, and there probably is a library out there someplace, but I couldn't find it. Went to the Arduino code, and I found a Bluetooth audio library for this. It's not really good, it's not reliable, but it works unless I break wires when I'm transporting the thing. And so that's what I went with. Now the difference between the two is surprisingly little. You know, you might be a little, some people might disagree with that, but when I'm looking at it, Python and Arduino code, or C or C++, yes, they're radically different, but in implementation, the way things work these days, it really is not as different as I expected. Python, of course, anybody use Python of any sort? Okay. So it's all about spacing and you block things off with spacing. It's object oriented. Reminds me a lot of Pascal back in ye olden days. Any Pascal programmers here? Okay, I'm not the only one. Okay, a few of us are willing to admit it. Just a few of us. It really reminds me of that. It's very similar. Python is not. It's got its own space and tab-based formatting, where Arduino uses the curly brackets to open and close, begin and end, things like that. It's much more similar to a C or C++ or JavaScript type syntax. But in reality, it's not that different. And what it came down to me for the choice is simply what's available, what libraries are there. If you've been programming for a while, and if you're willing to spend a little time looking at things, the language matters a lot less. If you're working on mission critical stuff, of course, I'm not going to say that. In military or regulated, that's all important. But so many things, it's just whatever tool does the job. And once you have the logic for the programming, it doesn't really matter what the language will do, as long as the libraries are there and the support is there, and you can get good documentation, which is simply the internet these days, as long as you stay away from letting artificial intelligence write your good-looking but bad code. So I've got some examples here. So starting up, you've got to load your library. So on the left, and that may be a little small, I apologize for that, but on the left, you've got your # include and your library. On the right, in Python, import your library. Different word, it works the same thing. You put it in about the same place in your quote. Arduino is a little bit more picky about where you put things, but not that much more. When you're declaring pins, you've got to declare pins in your Arduino, so you define the pin name and the number. Same thing in MicroPython. And the way you're recognizing a pin will vary a little bit based on the particular library that you're using. But again, it's all really well documented. So there's not an awful lot of difference. Bring your libraries in, define your pins, creating variables. In both of these languages, you don't necessarily always need to declare variables ahead of time. There are plenty of times where you can do it in the middle of code. I don't like doing that. If nothing else, for documentation purposes, I like declaring any global variables in a place that's clearly a global variable. Arduino is really variables. You have to hard type your variables. With Python, it will automatically type them, although the typing tends to be a little more critical in Python than in the Arduino. You can sometimes add to a character value, and you'll end up with just a different character. But still, you're defining a variable, and here in Arduino, I'm specifying the type. Here, it's determining the type. But I put them ahead of time if it's a constant or a global variable, so that anybody going through the code, which generally is just me, I mean, I do have this stuff on GitHub, but not many people go there. So it's clearer, it's easier to go back and edit. But again, not really much difference between the two other than the specific syntax. So object declarations, they both can be object-oriented. Python is generally thought of as an object-oriented language, but you can use it without being object-oriented. Arduino has some object-oriented capability as well. Both of them you can use as a functional language or object-oriented, but just depends on what you need. But again, you've got a different syntax for your object declaration, but you're still declaring an object. Still declaring an object. So it's really not that different. Let's see. You've got functions that you call. So you've got your curly brackets. This is one of the big differences is in the syntax where your curly brackets start and stop. With Python, you can define essentially macros or helper functions, but it really works in a very similar manner. And then Arduino, you have your setup section. And the setup is executed first. I like to do the same thing in any other language I'm doing anyway. So I create my own setup section, and this is when you're stuffing variables, you're setting parameters to your objects and things of that sort. So it just kind of makes sense that way. And then you've got your main loop and function. So I guess the message that I'm trying to get across here is it's really not that different between the two different languages. With MicroPython, in most of these things, you plug this in and it looks like a disk drive. So you write your code and then you copy it over. With the Arduino, it has the IDE, and you use that for developing and upgrading. The disadvantage of both MicroPython and the Arduino setup is that you really don't have any decent debugging capability. You really don't have any decent version control. So if you're working on a team, or if you're writing a lot of code and then going back and executing in it, seeing what happens, it's more difficult to do it that way. The discipline isn't built in. And debugging something like Python or the Arduino, what I tend to do is I write smaller sections of code. So I'll write a little bit, test it, write a little bit, test it. It's kind of annoying because if the whole system is in my head, I'd rather get it all down there, but debugging just becomes unwieldy when you're doing that. Now, if you're using the C or C++ languages in Eclipse or something like that, actually I've never done that with one of these, so I don't know what their debugging capability is, but I know some microcontrollers obviously do have that, and it's a huge, it's really important. Now let me see if I can, let's see here. So watch behind the radio there. You notice how the lights go. So that's really the difference. All of that work so that it would do that instead of just come on. But, that's kind of what being a maker is all about, really. So there's the and now for demonstration number 2. I am not actually using the tube amplifier. So those are neopixels, which I guess I forgot that part. So the actual circuit, what I've got is the ESP32. I've got a Class D digital amplifier connected with an I2S I2S. A little Life Holly board that I designed, charger board that I designed, and this speaker here. So the neopixels, RGB LEDs, they go behind the pilot lights and behind the tubes to give you the effect.
Just that little Class D amplifier is driving your.
Yeah, so it's not very loud. It's a 2-watt amplifier. Well, I don't know what's going on here. I was going to show you my amazing numeric keypad device. Okay, so let's see. Okay. Okay. So, it's really important. We've got some data entry to do. And I may have knocked some wires off when I... Oh. Yeah, okay, well... Well, you know... Again, dating myself. If Bill Gates can go up here trying to show off Windows and something goes wrong, then I can do it too.
That must be pretty bad.
Yeah. Besides, it's old technology. Okay, well, I've broken both of these on the way here, so. But had I not, all of that work and the number 5 would have shown up there. Any questions? Any?
Do you consider yourself a phone freaker?
I have a freaky phone.
Yeah, but you know the term. Yeah.
Yes, I do know the term.
Yeah. Would you consider yourself somebody who appreciates that space at all?
You know, I had friends who actually did that, and I actually met Steve Wozniak. And, you know, Apple Computer got their start in part by building blue boxes that allowed them to make free long-distance phone calls. So, you know, I know people, but no, I never actually engaged in that.
Do you have online, documentation of what you did?
I do, and I believe these are all available. The presentations are all available with Crowd Supply, and that has the GitHub, which has my software, the Bluetooth library, the place where you can get the ESPs, the story of the rotary phone, and of the radio. Both of those are on Design News, so it is available. If you want, you can grab one of my cards and you can get there from there. Anything else? Yeah, it's just, you know, it's a lot of fun. Even with this thing, I didn't want to gut it because someday I may go in there. So the only changes I made to the electronics were I unsoldered the original wires to the potentiometer and switch there. And so I'm actually using this switch and potentiometer feeding into the ESP32 there. again, I broke the wires, but had I not done that. So this is actually the volume control, even though it's not connected to the rest of the radio. So excuse me?
Does the tuner knobs do anything?
The tuner knobs do not. In my mind, one of these days I'm going to have the tuner knob switch to different internet radio channels, but whether or not it...
Between them, so it's like
Nice.
Yeah, and so I may do that. That's kind of in the back of my head, but whether I get to it or not is another story. If I'm back here next year, that probably means I got to it. So.
so what? So on the phone, what's the end goal in terms of after? I guess you've completed the diamond.
It's just, you know, it's kind of like the most useless machine. It's the slowest way to enter the numbers 0 through 9 in your computer. So, and that's the 0 is worth mentioning because it actually has 10 pulses. So I have to drop the top digit off of that to get 0. And in the old analog exchange systems, they did that mechanically. So yeah, the world's slowest data entry system. And that's said by someone who's used punch cards.
I was going to say, punch cards?
You could make a pretty sweet macro pad out of that, though. You've already got everything for that. So like
Oh, yeah.
dial 1 to control, copy something, whatever.
Yeah, so I can program this to send anything in there. Right now, it's using the standard PC keyboard codes, which isn't ASCII. It's close, but it's sending the keyboard codes out. So I could send, a data stream. I could send anything out there. Anything from hooking it up to a VoIP to, call home to, to go to my. Those could all be website URLs. If I wanted. So from that perspective, it's maybe a little more useful, just as fun. Okay, well, anything else? Any other questions? Thanks for sitting here.